Hi, my name is Peter. I wish to welcome you to Fiber 101 at STL. Optical fiber is at the heart of communications network. It took over from copper cables in the 70s and revolutionized telecommunications. Today, optical fibers run through millions of kilometers over land and on seabeds, connecting every corner of the world. In 2019 alone, enough fiber was led to pull yourself to the moon and back a good 430 times. So, how did optical fibers come to be and what made the world choose them over copper cables? Well, since the invention of telegraphs and telephones, copper cables have been connecting and serving the world. However, they carried information in the form of electric pulses, which resulted in heat generation and high losses. This required installation of repeaters at short distances to regenerate the lost electrical signal. With the rapid expansion of communication networks, there was a need for more efficient mode of transmission. So, by the early 70s, engineers had developed flexible strands of ultra-pure glass, as thin as a human hair, called optical fibers. These fibers had higher bandwidth capacity, could carry signals over longer distances, faster, and at much lower signal loss. They were, thus, both space and cost efficient. One optical fiber today carries multiple signals of different wavelengths in the same time in the form of light, each representing a separate data channel. Hundreds and thousands of these optical fibers are bundled to form an optical fiber cable. But how exactly does light travel inside the strand of a glass? As light moves from one medium to another, it bends a little. If the light hits the surface of a particular angle while moving from a denser medium to a rarer medium, complete reflection of light takes place. This phenomenon is called internal reflection, and it is the principle of which optical fibers work. Optical fibers is made of 1. The core, and 2. The cladding which surrounds the core. Glass used in the core has higher refractive index than glass used in the cladding, making the core denser than the cladding. Using the principles of total internal reflection, light is trapped inside the core as it's guided along the length of the optical fiber. However, while traveling through the core, it also spreads through a slightly larger area, including the inner edge of the cladding. This effective area is the fiber's mode field diameter, or MFD. There can be two types of optical fibers: single mode fibers and multi-mode fibers. Single mode fibers. This is the most widely used fiber, having a very narrow core of around 9 micron. It is ideal for long-haul signal transmission applications, such as across campuses, underseas, or in remote offices. So multi-mode fibers. These have higher light carrying ability, but due to a larger core diameter of 50 or 62.5 micron, they simply connect in applications like data centers. Above a certain wavelength, known as cutoff wavelengths, a fiber supports only a single mode. Currently, single-mode fibers are optimized to operate at 1310 and 1550 nanometers and 1625 nanometer wavelengths, whereas multi-mode fibers operate at 1850 and 1300 nanometers. Does that mean optical fibers can carry signal without any losses? No. Any mode of signal transmission would have losses, but degradation of signals inside an optical fiber is much lower over long distances in comparison to electrical and radio signals. In optical fiber, major causes of losses would be attenuation, which happens due to absorption and scattering of light inside the core, or microbends, which are actual distortions or core cladding interface caused majorly by the local mechanical stress placed in the cable during manufacturing or packaging, or largely due to microbends. Microbends is the result of light leaking due to cable bends beyond the specified bend radius during installation. With the use of bend insensitive fibers, however, like Bolide Enhanced or Stellar, bend losses, both macrobends and microbend, can be reduced drastically. Stay connected to know more about optical fiber and allied products. For more information on STL's range of optical fiber, please visit our website or contact your STL sales representative. Thank you so much.